Let's take a look at the structure of circuits with different types of control. Here we have the manual operation of a directional control valve as a final control element. In the pneumatic control, there is a clear differentiation between the control part, left, and the power part, right. Here the signals are generated and logically associated in the pneumatic control part, and the final control element is pneumatically actuated. In a corresponding electro-pneumatic control, there are electrical signal elements in the control part. In this case, signal processing is not carried out by a special device, but by connection of the various signal elements in such a way as to produce the function. The directional control valve, or more accurately, the solenoid valve, is now actuated electrically. This type of control part can, of course, also be used to control a hydraulic power part. Then we have an electro-hydraulic control. Now let's take a look at what happens in practice. The elements of the control part are, of course, distributed throughout the entire system. The signal elements, here the push buttons for operation, the sensors, and the solenoid switches on the pneumatic cylinders send electrical signals to the machine controller. From there, the solenoid valves are controlled. So here we have the interface between the electrical signal part and the pneumatic control part. Also in the elevator, these two areas are clearly differentiated. The controls in the elevator and on the door, and the sensors in the shaft which report the position of the elevator, together with the controller, form the electrical control part. The solenoid valve is the interface to the power part, consisting of the power pack, the valve in its function as a final control element, and the hydraulic cylinder. These systems also demonstrate why hybrid systems are used. For the large distances involved in the lock, electrical lines and electrical control energy are of course much more economical than a hydraulic control system. And in the case of complex machines like this automatic assembly machine, it is not only the many control lines and controllers that speak for an electrical control part. The logical association of this huge volume of signals is only feasible with an electronic controller. So here we have a complex example of an electro-pneumatic system. And in the case of the elevator, the power part requires huge forces, which is naturally not the case for the control part. So here too, a hybrid system is the right solution, electro-hydraulics. Yet another advantage of a system with an electrical control part. If electricity is available at the machine anyway, monitoring elements and indicators such as buzzers and lamps can be cheaply and easily integrated. And of course, the power part can be supplemented with electrical drives, such as an electric motor. In electro-hydraulic systems, electricity is also found in the hydraulic power supply part. The hydraulic pump of this power pack is electrically driven.